Hey A&Pers, this is Dr. Jones checking in. This is A&P 1 lecture test 4. We're on Noteset page 5. That makes it video 4. So, sarcomeres. Sarcomeres are the contractile unit of muscle. It's the smallest functional unit. And it goes from Z-line to Z-line, which we have talked about on a face-to-face class. We've had this conversation in lab already, so it might be worth your time to stop and go watch the first few lab videos and come back. Okay. So Z-line to Z-line, it's all the same information though that you're about to get. So each sarcomere, each myofibril, is made of 10,000 sarcomeres-ish, 10,000. The little squiggle there is the math for about, or historians would say circa, which means about. And math people say squiggle, kind of like a tilde, and it means ish. That's the math term for ish. About 10,000 sarcomeres end to end. It's like a when you stack the markers end to end, there's a marker and there's a marker. And when you stack, if these were individual sarcomeres stacked, they would make a myofibril. And the sarcomeres are made up of myofilaments. So sometimes people will say, we're going to whiteboard now. That didn't whiteboard. White screen. Okay, so we had our triangle. And we said the whole muscle was surrounded by epimysium. And the whole muscle is made of fascicles. Muscle fascicles. And the muscle fascicles are surrounded by perimysium. The muscle fascicles are made up of muscle fibers, which are just the cells. And each muscle cell is surrounded by and electrically isolated by the endomysium. And this is the term we pick up in lab, but we don't have epimysium or perimysium on any of the models. So in lab, we'll start with endomysium surrounding muscle cells on 2 of the 3 muscle cell models. Okay. And then we cut off, because those were all the terms you knew at the time. So let's fill in the rest of our triangle, which is on top of Noteset page 3. So each muscle cell is made of myofibrils. I'm recording. Sorry. And the myofibrils are each surrounded by sarcoplasmic reticulum, the sweater sleeves that surround each myofibrils. Sarcoplasmic reticulum surrounds every single myofibril. And the myofibril, if you look at it, has parts. And those parts, you can either break it down into sarcomeres. It's a C. Or the constituent myofilaments. And as you may recall, the myofilaments and sarcomeres both are made of thin filaments, which are mostly actin. We'll get there. And thick filaments, which are myosin, except for the central core of titin, but we'll get there. Okay, so myofilaments are the thin filaments, which are mostly actin, and the thick filaments, which are mostly myosin. The thick and thin filament interaction is what makes a muscle contraction. And you can also say the myofilament interaction is what makes a muscle contraction. And the sarcomere is the smallest unit of the muscle that contracts. And that'll be true of skeletal muscle and cardiac muscle. Smooth muscle is completely different, although it does have actin and myosin, but it's more of like a mesh net around the outside. And anyway, but we're primarily talking about skeletal muscles. Here we'll talk about cardiac and smooth at the very end of chapter 10 for the last 2 sections, a page. Okay. Contractile unit of muscle, smallest functional units are sarcomeres. And each myofibril is made of roughly 10,000 sarcomeres end to end. For a while, my kids measured things, and I've been teaching this class for a long time. And so I always have lots of expo low odor markers around, dry erase markers around. And my kids used to stack these end to end and measure things, and they'd tell me, okay, I'm like however many and a half markers tall. And they went around and measured like everything in the house with markers, but measuring is part of math, and so, you know, totally going with it. It's a math thing. Okay, so the interactions between, and again, you can say thick and thin filaments are responsible for muscle contraction. You can say the interactions between the myofilaments are responsible for muscle contractions. It's the same thing. Okay, and the striations are the stripes. No, not in show. Unwhite. There we go. The striations are the stripes. There are dark, thick filaments, which are the A bands, and light, thin filaments, which are the I bands. There's more to it. We'll get there. Okay. The A band is the length of the thick filaments. So what happens here, as you can see in this light micrograph, the thick filaments, those little dark stripes, the thick filaments are physically thicker, and so less light gets through, so they're darker on a light microscope. So they're thick filaments. And those are the A bands because they're dark. Dark A bands. The thin filaments are thinner, and so more light gets through in between the thin filaments. And so these are the lighter stripes. I'll make it cursive L, I. The I bands are light, I for light. Because they are the thin filaments are just physically thinner, so more light gets in between them. They're the same, centered the same distance as the thick filaments. So. Okay, so the A bands are the length of the thick filaments because they're thicker and darker. Anywhere there are thick filaments is the A band, and it is dark, as we've said. There are 3 subdivisions of the A band. The M line is down the middle, get it? M in the middle. And it's the middle of the A band and the middle of the sarcomere. Remember, the sarcomere goes from, Z line to Z line. I overshot it. From Z line to Z line. So in the middle is the M line, middle. And then the H band is the area around the M line, which has no thin filaments. So here, the thin filaments are red in our books, and the thick filaments are blue. So here in the H band, you have blue thick filaments, but no red thin filaments. And then the zones of overlap are the zones where the thick and thin filaments overlap. So I do sometimes call them the zones of overlap. Sounds like dinner's ready. Okay. Thick and thin filaments overlap, and as you can see in each, this is a picture of one sarcomere, and you have two zones of overlap because you've got one on either side of the H band. There are two zones of overlap in each A band, and the A band is from here to here. Okay. And you should know that a triad surrounds each zone of overlap. We said the triad is one T-tubule with two terminal cisternae on either side. And we said about the T-tubule that it was excitable, that it was part of the excitable sarcolemma that grows inside the muscle cell and brings the excitement. It brings the muscle action potential, which is the excitement, to the inside of the cell. And then it is touching the two terminal cisternae, one on either side. And we said the terminal cisternae have voltage-gated calcium channels. So the excitement actually is what opens the voltage-gated calcium channels and releases the calcium into the sarcolemma. And it's the calcium binding to a protein that we haven't learned the name of yet that makes the muscle contract. And so the zones of overlap, where and we said the thick and thin filament interaction is where the muscle contraction happens. And now we're saying that we've got a triad around each zone of overlap so that we're releasing the calcium right where it needs to bind to cause the muscle contraction. I blink 3 times so you know it's important. Plus, I feel like I should stop talking every now and then and let it sink in for a second, because that was important. Yeah, just rewind and listen to it again. You need to know this. Okay. And a triad surrounds each zone of overlap. As a result, the calcium is released right at the thick-thin filament interaction where you need it to cause the muscle contraction. Okay, let's talk about the I band. The I band is where there are thin filaments but no thick filaments. So here's an I band and I band. So the I bands contain thin filaments but no thick filaments. And in the middle of the I band is a Z line. Here's a Z line. And the Z line has a distinctive zigzag appearance. It's made of actinin, and it marks the ends of the sarcomeres and is in the middle of the I band. So here's the I band, and the Z line is in the middle. Sarcomeres extend from Z line to Z line. So let me switch to magenta here. So Z line to Z line is a sarcomere. And then from this Z line to the next Z line is a sarcomere. This is so much easier when I'm drawing it on the board and I can see in your faces if you're with me or not. And then from Z line to Z line is a sarcomere. Sarco. Sarcomere. A little bit. So the sarcomeres are stacked together to make a myofilament. So all the sarcomeres together are a myofilament, which is surrounded by sarcoplasmic reticulum. And each sarcomere is made of myofibrils, the red thin filaments and the blue thick filaments. And you need to know about titin. Is titin on the next one? No. Okay, so titin, need the green, is this green squiggle, and it goes from the end of the thick filament and attaches to the Z line. And so it keeps the sarcomere aligned. It keeps those crystals lined up correctly. Now you can stretch out those sarcomeres. You wouldn't stretch them out so far to unalign them unless you broke a bone. But if you were to break a bone and you stretch those out so far without anything to line them back up, if they heal wrong, then that muscle doesn't work anymore. Bad. So we've got the titin, the springy green titin there. It's not actually green in the body, it's just thick and thin filaments aren't actually red and blue either. Okay. And so if it were to get overstretched, then the titin is in between and allows them to line back up so that that muscle is functional for you again. Let's do the quiz slides. Okay, so what's number 1 here, where there's thin filaments but no thick filaments? That's an I band. And what's number 2 here, which is the length of the thick filaments? It's dark, so that's the A band. Number 3, here's the area where there's only thick filaments and no thin filaments. It's the center of the A band. It's the H band. Sometimes they call it the H zone. 4 is the zigzag, so that's the Z line. 5 is the green springy. That's the titin. Let's see, where's 6? Down here is got thin filaments and thick filaments overlapping, right? That's the zoo, the zone of overlap. 7 is the line down the middle, M line. 8 is Z line to Z line. What's that? You got it, that's a sarcomere. Merely a sarcomere. Let's see, this was supposed to land on the red line, but I couldn't get it to work. The red line is the thin filament. And this one's land on the blue line. The blue line is the thick filament. Together they're called myofilaments. Excellent. Now we talked about what the Z line was made of. What's the Z line made of? Actinin. And what's the thin filament mostly made of? Actin. And what's the thick filament mostly made of, except for central core of titin? Myosin. And then the common term for thick and thin filaments, and then the sarcomeres all lined up make a myofibril. So be careful with this myofibril versus myofilaments. They look alike, they both start with MYOF, and it gets a little confusing at times. But the myofibril is all the sarcomeres stacked up, and the myofilaments is the group term for the thick and thin filaments, the actin and myosin together. Okay, let's see if we have another quiz. Oh, we do. Okay, so the whole muscle is surrounded by epimysium. The whole muscle is made, here's the whole muscle, surrounded by epimysium. And then each of these is a muscle fascicle. That's not gonna fit. And it's surrounded by perimysium. And each muscle fascicle is made up of individual muscle cells or fibers, and they're surrounded by endomysium. And they're made up of, what are those little red dots, little rods? They're made up of myofibrils. And the myofibrils are surrounded by sarcoplasmic reticulum, and the myofibrils are made of myofilaments. Which are organized in sarcomeres. Got it. Do we have another quiz? Nope, that's the next page. All right. So this has been, what has this been? AP1 Lecture 4, Video 4 on page 5. So thank you as always for tuning in. The education must go on. Dr. J.